Isosceles and equilateral triangles. When we're identifying parts of a special triangle, we want to talk about the isosceles and right triangles. Isosceles triangles, remember, are defined as triangles that have at least two congruent sides. So those congruent sides are called the legs of the triangle. And then the third side that is not congruent to the other two is called the base of the triangle. Then those two angles that appear on the base of the triangle are called the base angles. In a right triangle, the two sides that create the right angle are called the legs of the triangle. And that third side, which is opposite from the right angle, is called the hypotenuse. Make sure that you know these terms because we're going to use them a lot. The isosceles triangles theorem. It states two sides of a triangle are congruent if and only if the angles opposite them are congruent. So again, we're reviewing our logic here. This is a biconditional statement. That means the conditional statement and the converse are both true. So if two sides of a triangle are congruent, then the angles opposite them are congruent. And also, if two angles of a triangle are congruent, then the sides opposite them are also congruent. So what this looks like in a triangle is if we have two sides that are congruent, then the angles that are opposite from those sides are also going to be congruent. So whichever legs are congruent, that means the base angles of the isosceles triangle will also be congruent. So let's do a little bit of practice here. In this first one, we need to find the measure of angle A. Now, if you look carefully, we have these are the two congruent sides, so we want the angles opposite from them. This one is measured 70, and we're actually looking for angle A, which means that the measure of angle A is congruent to the other given angle, so it's going to be 70 degrees. Now when we're talking about example 2, look carefully. We're given again these two sides that are congruent, so that means the angles opposite from them are also congruent. So angle D and angle F are the ones that are congruent, but we don't have any measurement for angle F so that we can easily find X. So we have to do this another way. We are given this angle E, which doesn't seem like it's going to help us, but think carefully. If D and F are the same and D is marked with X, that means F is also X. And you know the three angles of a triangle add up to 180. So we can take the 30 plus X equals 180. So if we solve this equation, we have 30 and then 1x plus 1x is 2x equals 180. And then we want to subtract 30 from both sides. And then we're left with 2x equals 150. And then we want to divide both sides by 2. And I'm going to write my final answer up here. X is equal to 75. Now we're going to take that same idea in example 3 and find the value of X. So again, here we find our two congruent sides, and then the angles opposite from them are congruent. But we run into that situation again where we have one of the measurements but not the other. So since we know that they're going to be the same, we can go ahead and label this one 3x plus 8 as well. Then we can add up the three angles in the triangle and set it equal to 180. So 3x plus 8 plus 3x plus 8 plus 2x plus 20 equals 180. So again, on this left side, first we want to combine like terms. So 3x plus 2x gives us 8x. And then 8 plus plus 20 gives us a positive 36 equal to 180. And now, in order to solve for x, we want to subtract 36 from both sides of the equal sign. And then we're left with 8x is equal to 144. And then last, divide both sides by 8. And we get x is equal to 18 as our final answer. Next, we want to talk about the equilateral triangles theorem. Now this states that a triangle is equilateral if and only if it is equiangular. So again, the conditional and converse are both true since we have a biconditional statement. So if a triangle is equilateral, then it is equiangular. If a triangle is equiangular, then it is equilateral. So basically, if you have 3 congruent sides of a triangle, then you know that the 3 angles are congruent, and vice versa. So let's work out a couple example problems. In both of these, we want to find the value of x and y. So here we have 3 congruent sides, which means that we are going to have 3 congruent angles. Now, you can do this calculation every time, but it would be good of you to remember. We did talk about this in our introduction to triangles, but we'll go through it one more time. You know that the 3 angles of a triangle all add up to 180 degrees. And if we have 3 that are all exactly the same, then we can divide that 180 by 3, and that gives us 60 degrees. So that means that x is equal to 60 degrees. So again, I highly suggest that you jog it to your memory that each of the angles in an equilateral triangle is 60 degrees. Now when we're trying to find the value of y, you can do this 2 different ways. First, if you use the exterior angle theorem, y is going to be equal to the sum of the 2 non-adjacent interior angles. Since this angle is 60 degrees and this one is 60 degrees, y is going to be equal to 60 plus 60, which is 120. The other way that you could look at this is that x and y are actually a linear pair, meaning x and y have to add up to 180 degrees. So, since x is 60, if you subtract that from 80, you're left with 120. Either way, you should get the same answer for y. In the second example, again, you can walk through the steps again. Since we have an equilateral triangle, that means it is also equiangular. And if you remember that each angle is equal to 60 degrees, then you know that this angle marked 4x is equal to 60 degrees. So we can just divide by 4, and then we'll get x is equal to 15. Then, likewise, to get y, same idea. You can use the exterior angle theorem, or you can use the idea of linear pairs. In any case, y is going to equal 120. And that's our final answer. That's it for this video. I'll see you in class.